Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
So we're in the fourth part of this problem. In this problem, we're told to read in an Excel document. It's not an Excel document, CSV document. It's got, so this is right here, and I downloaded that into this folder, which is over here for the project. There's that CSV file, and I'll open the file over here. It's got three fields: mobility, state, and population. So population is like the number of trials, N, and mobility is the proportion of the, so it's like a proportion of people who have moved up economically. So that's a p-value right there. And this is for different communities, and their states are given, names of their states are given. So let's go back to coding, and this is the let's do D4, and I'm copying the D3 portion of it. So D4. Okay. So the way you read it is through this command called read CSV, and I wrote that in here. So this is the command. This basically takes in the file. Notice the forward slash is in the this causes a problem if it's a backslash. So this is the file name with the path, economic CSV. We're reading that into economic variable, and the variable basically becomes a data frame. So that's what it looks like, economic, after we read it. So we're going to add a field to this called SEP, which is going to calculate the standard error of proportions for these populations and mobilities. So let's do that over here in the next. So we're going to add it by doing this: economic SEP equals to standard error proportions, and we said the proportion would go first, so economic goes economic. Mobility is the proportion, and economic population is the number of trials, and that should give us SEP. Okay, so I'm going to run that. Oh, it couldn't find it because I didn't run the whole thing. There you go. So let's run economic again, and this time you'll see that this has an SEP folder, SEP field to it. Okay. So next, what we need to do is we need to get the histogram. So we need to get the mean of economic SEP, but this is going to have some non-numerals, so I'm going to as numeric, and then we're going to say remove all the non-applicables. Yeah, so that should give us, let's cap that out, cap, comma, mean equals to this. So that should throw us a, if I source this, yeah, so that gives us the mean. I'm going to do it for the other, oops. So this is going to be standard deviation. This is going to be variance. This is going to be minimum. And then maximum. And those are our values that we need for summary statistics. So that's number 4 right there. Okay. So in this one we are going to do so D5. We are going to do a histogram of standard of errors that we just calculated. So this is going to be D5, and I'm going to cat that too. Let's copy it from here because I sometimes mistake. See, there you go. D5. All right. So this, I'm going to make a plot, and I'm going to call this D5 hist. That way we can keep track of it. And this is going to be a GG plot. Yes. And it's going to be on the data frame called economic. So when you're doing a plot, it has to be in a data frame. And inside the data frame, the X value, because this is a histogram, the X value is going to be the SEP. And we have that calculated from the previous section. And then we are going to do a histogram, geom underscore histogram. And we're not going to be too fancy. We're not going to do anything else with it. We're happy with number of bins being 30, which is a default number of bins. And then we are going to plot this D5 hist. Okay. And we should be able to run this, source this, and there you go. That's our plot. And yeah, so onward to question number 6. So in this part we are told to do a scatter plot, not just a histogram, a scatter plot of the standardized errors, SCP in the y-axis and the population in the x-axis using ggplot2. Alright, let's try to do that. Let's copy this here because we're going to use a lot of the same code. So this is D6 now, and we're going to call it D6 scatter because that's a scatter plot. Okay, and this is also going to be, the plot is going to be D6 scatter. Okay, now we are doing a ggplot on the economic data set, and then over here we are going to do X. It's actually going to be Y in the Y is going to have the standard errors, and the X is going to have the population. And we can look at the population from here. It's over here. And that's the spelling. Okay, and then we need to do geom points, right? Yes. Let's see if they have points. Geom point. Okay, let's try that. So let's see what happens. So those are the points, and that's the population on the x-axis. The standard errors of proportions are in the y-axis, and yeah, those are the plots. So this is number 6. Let's go on to number 7. So in number 7, we are told to do a pretty similar thing, plot a scatter plot for standard errors in the y-axis and mobility in the x-axis. So it's going to have very similar code, and this is what the code is going to do. We need to label these correctly. D7. Now we're in D7 scatter, and we are still in the economic data frame, and Y is SEP, but the X is, I'm gonna copy the X from here so I don't get the wrong spelling, and that's the X, and we want the geom points, so that should do it. And this is sourcing it. Okay, so look, they are scattered, and it looks like it's as mobility goes up, the standard errors of proof also goes up. So it's got a linear sort of relationship. Note that our plots are basically right below each other. So this is, yeah, so those are happening right underneath. So this is the latest plot. Alright, so that ends number 7.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.